In this lesson, I'll be walking you through the pre-lab, the preparation for the lab for the single replacement lab. You'll be doing some predictions for this lab, predicting whether reactions will occur or not. And I'll show you how to do that on your Google document that I made for that purpose. So in your Google Chemistry folder that I prepared for you, I have a document for you to do this pre-lab prediction work. In addition to that, in your lab notebook or your lab logbook, you're going to have to write a set of procedures, summarize the procedures for this lab. And lastly, you're going to have to summarize the hazards that could potentially occur working with the chemicals we'll use in this lab. And I'll show you how to get to that information and to summarize. Okay, folks, in preparation for your single replacement lab, you need to find your Google document for your pre-lab. So I'm in one of the Google folders here, and if I look carefully, I'll see where it says Unit 5, and there's two documents here that say single replacement. We want to look at the student pre-lab to start with. Look for the student pre-lab to start with, and click on that and open it up. Now when you get there, you will see this. It's not really a table because I don't have a formal table label on the top, so it's a chart. But your chart doesn't have these things here filled in. I filled a few of these in just to get you started. Okay? This is your pre-lab. So before you do the lab, you have to do several things. One is to complete this pre-lab. Okay? You have to do this pre-lab first. You also have to do hazards for the chemicals and procedures for the chemicals. Okay? Now I sent you emails about some of those, everything but the hazards. The hazards I want to go over with you in class today a little bit. So this has to be completed. Now if you're there in your computer, you'll see what I put in here for the first row. All right, so you've got already printed in there, put into your graph or your chart here rather. You've got zinc here in this first cell and zinc nitrate in the second cell. And what the point of this is that it's asking you that if you put zinc metal in a solution of zinc nitrate, what will happen? You're making a prediction about what will happen based on the stuff we've been learning about solubility rules. Okay? So you're going to be using, I'm sorry, not solubility rules, but activity series. You're going to be using this activity series right here to make these predictions, okay, in your test preferences. So I said here this reaction will not occur. And I said zinc, the metal, cannot replace zinc, the ion, in the zinc nitrate compound. And the reason it can't do that, and I didn't really finish that, the reason it can't do that is zinc, the metal, is not higher on the activity series than is zinc, the ion. Okay? I'll be glad to elaborate more because I'm going to show you that. So on the activity series of metals right here, zinc cannot be higher than zinc, the ion, because they're in the same row.
So zinc, the ion is the second column.
Yeah.
What's the first column?
Zinc, that's the metals. Okay? So in order for zinc to replace something, it's got to be higher. Not the same level, higher. So zinc won't replace zinc. That make sense? Okay. It's really pretty simple. If it's not higher, it doesn't replace. Okay? Let's look at the second one here. In the second one, we are comparing. I'll get my mouse to work there I want it to. Yeah, it's in there somewhere. I know it's there. Come on. There we go. All right. We have zinc and silver nitrate. So if zinc is by itself, zinc the metal, is put in a solution of silver nitrate, will a reaction occur? Let's go over to the activity series. And zinc is right here. Silver is down here. So zinc is clearly higher than silver, so zinc should be able to displace a silver ion from a solution or from a compound. So going back, hold on one second, going back up here, since zinc will replace silver in the compound, my prediction is this reaction will occur. And the reason I'm saying that, the explanation, is that zinc the metal is more active than the silver ion and the silver nitrate compound. We know that zinc is more active because it's higher on the activity series of metals than is silver. So I'm just simply saying this will happen or it won't happen and explaining why. So I had a question about how to make subscripts. Okay, if I type that 3 there and I want to make it a subscript, I'm going to hold down the control key, which is the lower left hand side of the keyboard, and I'm going to click the comma button, and there's a subscript. Okay, if I want to make it a superscript, I hold down the control key and hit the period button. So it's comma for subscript, period for superscript. Okay? Huh? Yeah, there's a different set of shortcut keys when you're using Microsoft Excel and Word. Okay, but that's what works with Google. Now, let's go down here to zinc and what's the name of this acid? Wow, we learned to name these things. Come on. It's a binary acid, so it has a what kind of prefix? Hydro prefix. And ides become ic, so that's hydrochloric acid. Okay, so we're combining zinc in a hydrochloric acid solution. Okay, and I'm saying the reaction will occur, and here's why. Zinc is located here on this activity series, and there's the hydrogen ion in an acid. Okay, so zinc, the metal, will displace hydrogen in an acid. All right. And that's my reasoning. If you go back here and look what I said about it, I said that zinc, the metal, is more active than the hydrogen ion in the hydrochloric acid. Okay? We know that zinc is more active because it is higher on the activity series of metals than is the hydrogen molecule. The hydrogen molecule is H sub 2. And the hydrogen ion, that's H with a superscript plus sign. Okay? And it just refers you to your test references to figure that out. Okay? All right, last one as an example. We're putting silver, the metal, on the left, in the left column here I've highlighted, in a zinc nitrate solution. Okay? Going back to the activity series, here's silver, and there's the zinc ion right there, the Zn with a 2 plus superscript. So silver, the metal, has no charge. Okay? Any element that's by itself or is only bonded to itself, like hydrogen's bonded to itself to make H2. Any element by itself or only bonded to itself has a 0 oxidation number. Okay? So silver, when it's by itself, has no charge, no oxidation number. Zinc, when it's bonded with something, is going to have a 2 plus charge. Silver by itself has no charge. If zinc were by itself, it'd have a 0 charge. All right, but the ion of zinc has a 2 plus charge. All right? So silver is lower on the activity series than zinc the ion. And by using this activity series, we would say that silver cannot displace zinc, and so no reaction would occur. Let's look at what I predicted here then. I said this reaction will not occur. That's my prediction. Then I said why is this? Silver, the metal, is less active than the zinc ion and the zinc nitrate. And I said we know that silver is less active because it's lower on the activity series of metals than is zinc. Okay? So you're going to complete filling out this chart here. Okay? I've basically given you 4 of them, and there's 20 altogether. And you know, one of the nice things about using electronic documents like this, and whether it's in Google or some other form, is that you can copy and paste a lot of things. So you can, you know, if you're using the same explanation every time, you can copy and paste one explanation somewhere else, just change the symbols or names or whatever that are there. So it can speed it up for you if you'll learn to use it. I just showed you this to help you get started. Now, turns out I also sent this to you by email. Okay, if you were checking your email, you'd know that you already have this in an email somewhere that you could type it in. Now, you can't copy and paste it because I put it in your email in a way where you couldn't do that. Okay? Now then, I want to jump down to the bottom of this document, okay, a couple pages away, and I want you to go there with me and get out your lab logbook. Go down there with me and get out your lab logbook. So you're gonna finish this, the graph, or not the graph, the chart here for predicting whether reactions will occur later. It's homework. Right now I want to show you what to put in your lab logbook to prepare to collect data for tomorrow's lab. Okay? Now this chart kind of gives you a good start on how to do that. All right? So if you notice in the first column here, I've got metals listed there. The second column, I've got all the solutions. It's just the same set of information as in this chart up here. Okay, but I've got a couple different columns here. This column is for observations. So in the lab, you're going to have a place for observations. Now, when I put it here, I didn't leave a lot of space for observations. You've got to leave a lot more room for observations in your lab logbook. And that's why I'm taking the time to help you see that. So let's go to your lab logbook. And let's make some columns here of this data. So let's see. We had zinc up here, and we had zinc nitrate. Okay? And so that's going to make two columns. All right? And so we had a column, the next column was for observations. So I have observations here. So here is where in the lab and during the lab, you're going to put your observations when you put zinc and zinc nitrate. Okay? That's what you're going to do in the lab. So you're going to complete this part before the lab. You're going to complete this column here during the lab. And you're going to complete this last column over here after the lab. Okay? Everybody understand?
Quick question.
Yes. What's your
Would
question?
you just like move it from the thing you shared with us to
Yeah, pretty much. Pretty much you just move it over there. Only you're going to leave more space for your observations, okay?
So you need to put it in both places so you can
Yeah. Yeah. So this part here is done before the lab. These two columns. This is done during the lab. And this is done after the lab. Okay? So this over here, this last column, once you have observations, then you're going to go to your Google document and look at your predictions. You predicted, or I predicted for you, this reaction would not occur. I have some observations during the lab. What I'm going to do over here is I'm going to look and say, do these observations stack up with the prediction? In other words, if my observations are good and my prediction's good, there should be no evidence of any kind of chemical reaction. Does that make sense? What kind of evidence would you look for to see that there's a chemical reaction? Huh? Bubbles might tell you there's a chemical reaction. What else? Color change might. Well, bubbles would be the formation of a gas, yes. Okay. So there are lots, and now you may find things that are going on that you didn't expect, but that might reasonably be assumed to be indicating there's a chemical reaction. That makes sense? So when you do observations, you want to make sure you have the evidence you need to support what you're going to say over here. Now what you're saying over here is what you're saying about the observations support of or refuting of your prediction. Okay? They're supporting or refuting the prediction. Support, refute. Now you don't have to label it the same way I do. And then you're also going to explain. And what I mean by explain is this. Let's say you predicted that no reaction would occur, but when you looked at the observations, there was an indication of some kind of chemical reaction. When you explain, you're going to explain, well, what could cause that? Why would I have some evidence of a chemical reaction when my prediction was that there would be no chemical reaction? Does that make sense? Yes? All right. Now, let's say that, what was the next set of things we were looking at here? Zinc and silver nitrate. So I'm going to skip down 1, 2, 3, 4, and leave 4 lines for this. And I'm going to put zinc and silver nitrate. We were just talking about this a minute ago. We said that zinc would react with silver nitrate in one of our homework problems. So if I have some observations that a chemical reaction occurred, okay, then over here I would say the observations support my prediction. And here's why. What I saw, that is whatever this was, maybe bubbles formed. Bubbles forming would indicate there was a reaction, or there was a color change. A color change indicates there's a chemical reaction. So you have to explain over here why you're saying it supports or refutes what you predicted. Does that make sense? All right, so you should have room for about 4 lines here for every one of these reactions, okay? So let's go and look, and we got zinc and silver nitrate, zinc and copper 2 nitrate, and then zinc and magnesium nitrate, and then zinc and hydrochloric acid. So when you make up your table and you come to lab, you should have all this done. All right, now you don't need these pencil marks up here. I'm just telling you what we're using those for, okay? What you do need at the top of this page, though, is the title for the lab, a page number in the upper right, and a date in the upper left. Always leave room at the bottom for people in your lab group to sign and date your work to show that they were witnesses to the fact that you did this in a lab. You got it? So you're going to need 4 pages here for your lab lab collection of observations. Okay, because if you look back over here in Google, zinc should all be on 1 page, silver should all both be on 1 page, copper should be on 1 page, and magnesium, and that continues to the next page down here, should all be on 1 page. Okay, that makes sense? So you'll have 4 pages for collection of data. Everybody got that?
Yes, sir.
All right. Something else you're going to need for your post-lab. Okay, let's talk about that, and that's hazards. So you're going to need hazards for all the chemicals we're working with. Remember, hazards are summarized. That means not every single detail that you look up has to be in there, but you have to have a reasonable summary. Okay? Now, one of the ways that I'm going to allow you to summarize for this lab is I'm going to let you summarize all the metals as one group. How many different metals are you working with here? 5 metals? 4 metals, right? Okay. If you look on the sheet here, let me go back up here and look at this. Here we go. Here, 4 metals. 1, 2, 3, 4. Okay. So what I'm going to let you do is kind of collect all of your hazards for metals as kind of one thing. So I'm going to go over here to a Google search page, and on my in my lab logbook, under hazards, I'm going to put all the metals like that, okay? And I'm going to list all the hazards kind of as one group. Even though different metals will have the different hazards, we're going to list them as kind of one group, okay? All right, so let's type in, our first metal was zinc, and let's just call it zinc metal. Now, where you're going to find this stuff is in what is known as an SDS, okay? SDS, you need to know what those letters stand for. It stands for a safety data sheet. SDS stands for safety data sheet. Now, if you ever have trouble finding a safety data sheet for a chemical, you can simply look it up as MSDS, because it used to be called, up until 2 years ago, it was called a material safety data sheet. But now it's just called a safety data sheet. Okay? So you can plug in just zinc metal and SDS. And you can choose to look out for it almost anywhere you want to. We can just plug it in like that and search for that. And we'll find lots of websites where they have zinc metal safety data sheets. Okay? But I always find that Flynn Scientific, which is the company we get most of our chemicals for our labs, from which we get most of our chemicals for our labs, seems to have a really super simplified for high school kind of safety data sheet. So I kind of like those. What I'm going to do is I'm going to put in the way that Flynn is spelled is F-L-I-N-N. Okay? And I'm going to put it in like that and just go find it. And there's a Flynn Scientific MSDS, and you can see it says MSDS right here in the top, and the name of it for Flynn Scientific. And just click on that, and there's your zinc metal MSDS. Okay? Got that? Now, we're looking for hazards, both health and fire hazards, okay? Now, this is first aid measures and firefighting measures. We don't need to know how to fight a fire, because you're not going to be fighting a fire. The only kind of fighting a fire you're going to do is if I catch on fire, in which case you might throw the blanket on me, or you might spray me down with fire extinguisher, but pretty much you're not going to be worried about this stuff, okay? That's for firefighters, for firemen. So really the only place you're having to look here for any of this stuff is under hazards identification. Okay, now you want to scan through here and make sure there's not something else listed for fire hazards that's not listed somewhere else. Just make sure you look at all that. But if we look under hazards identification, this is just a description of the chemical. You don't even have to worry about that. All you care about is where it tells you what the hazards actually are. Okay? Now there's a ranking for hazards, but I don't want you to worry about that for the lab. I want you to worry about only what it says are the potential hazards that might come up in a lab. Okay? So it says here that inhalation of zinc dust may cause lung irritations. Okay? Now what we're going to, since we're combining all the metals, we're just going to say all metals might, under those circumstances, cause irritation. Okay? Could cause lung irritation if dust is breathed in. So what I did was to take those words and make it in a little bit more colloquial type of way of saying it. All right, a way that you and I would understand if I said it more. All right, let's see what else it says about metals. This stuff, it can spontaneously combust. What does that mean? On its own. Okay, so zinc dust can just catch on fire with moisture in the air. All right, so I wrote down then that dust can catch on fire with or in contact with moisture in the air. Notice I made a mistake. So what I do, I drew one line through it. I don't scratch it out, I don't white it out. Okay, I don't tear it out. All right, one line, make the correction. All right, now you're going to continue with all the other metals. You're going to look up silver and copper and magnesium, and you're going to put all of that under metals. That make sense?
Yes, sir.
However, for the compounds, let's go back to all these compounds here, each of these have to have separate listings for hazards. Okay? Now, how many compounds do you have?
4.
5. And they repeat themselves, same compounds. See that?
Mm-hmm.
All right. So you're going to look up zinc nitrate. Well, let's go back over here and look up zinc nitrate. So instead of looking up zinc metal, let's look up a zinc nitrate SDS from Flynn. All right, well, that's the reagent. Turns out that if I go to the reagent, the MSDS is listed there, but also here is the MSDS silver nitrate. That's silver. Zinc nitrate. Here it is right here. But if I go to this one, this is where you look and buy this. If you were a chemistry teacher, you could buy zinc nitrate. But if you look down here, there's the MSDS or SDS listed on that page. So I could click right there and get there. So there's a couple ways to get there. All right. So this is a separate class, a separate thing you're going to write it out for. So under hazards, then we have metals, and then we're also going to have a hazard listing for zinc nitrate. Okay, and you're going to do the same sort of thing. You're going to look at this SDS, and you're going to say, okay, this is an oxidizing solid, may intensify a fire. You want to keep it away from heat. Skin and eye damage. It can damage your eyes and skin and cause irritation. Okay. I don't know if it's not something that's likely to happen in a lab, you don't have to put it down. But if it could happen in a lab reasonably, by exposure of some kind, then you can put it down. And summarize. And look, if the word doesn't make any sense to you, look it up before you put it down. Don't put something in your lab logbook just to think you're going to satisfy Mr. Tedder if you don't know what it means. Because if I ask you what it means, you got to be able to tell me. You got it? I mean, this is your life we're talking about here, your health, okay? So safety is really important. All right? So summarize the hazards for all these 5 chemicals. Got it? That'll be 6 hazards you need to list for this lab. Got it? All right, now, Last thing you got to do for the lab is you got to have a summary of your procedures. Okay, so in your lab logbook, you want to make sure you summarize your procedures. And it's not a real complex set of procedures. I hope you worked on this some before the day before the lab, but if you didn't, well, you got a lot of work to do tonight. Okay, but you want to summarize procedures. So when you come in here, you want to know what you're doing. All right, there's a video. You should watch the video before you come in here, and you can summarize the procedures from the video. It's probably easier to see the video and understand what you're doing than it is to read it and understand. But however you do it, you got to have a summarized set of procedures, and you absolutely need to watch that video because it'll speed up your getting the lab done and with less confusion. Okay, and whoever the lab captain is in charge of confusion. Okay, if your group is in confusion, the lab captain gets to dock points. Got it? And since you don't know who's going to be the lab captain until tomorrow, I suggest you make sure you're clear on how to get things done. All right? Any questions? So that's how you set up your lab. So procedures, hazards, you got to be able to collect your data, and you got to get your pre-lab done.